Okay, in this video we're going to be talking about permutations. Permutations go along with factorials. They also go along with combinations. When you have a regular combination problem, it's pretty simple. Let's say that you are going to a pizzeria and you want a certain type of pizza. There's 3 different sizes. There's small, medium, and large, right? There's also 4 different toppings. You've got plain or cheese. You've got pepperoni, you've got sausage, and you've got mushrooms. So there's 4 different toppings, 3 sizes. All you have to do is multiply, because remember, you can't add apples and oranges. You'd multiply 4 times 3, you'd get 12. So there are 12 different combinations of pizza. This is a little more complicated. I'm going to show you what I'm talking about, but it also involves real-life situations. I wrote a formula up here. I got a little n with a big P and a little r equals n exclamation point. In parentheses, I got a fraction bar actually. Then underneath it, I've got parentheses, n minus r, another exclamation point. Looks pretty ridiculous, but, and I know you think NPR, like the radio station NPR, no, that's not what I'm talking about. N represents one number, the big P stands for permutation, the R stands for another number, equals one part of it. Then you've got some sort of subtraction formula with another exclamation point. Forget about that for a second. Look at the situation here. I've got a play going on. There's a play going on down the street in the theater, and there's 3 roles available for this play. There's 10 actors that sign up for these roles. That could be a problem because 7 people are not going to be happy, because 7 people are not going to get this role. 10 actors, 3 roles, right? Now, I want to show you what I'm going to do here to solve this. I want to know how many different combinations can these actors get these roles, okay? So, the top part is the NPR equals n exclamation point, which in this case is 10 exclamation point. The first letter N is 10, okay? That's the given. Now I got to figure out what R is, okay? R in this case is 3, okay? R is 3. I'll put a little 3 right here. So I should say N is 10, R is 3, okay? Forget all this gibberish, all right? R is 3, but I'm not going to put a 3 exclamation point there because you'll notice that I have to do some subtracting. I have to subtract N minus R, or in this case, 10 minus 3. I subtract 10 minus 3, of course I get 7, right? So I'm going to slide that underneath with an exclamation point. So it's 10 exclamation points over 7 exclamation points is what it would be. What does this mean? Now I do a little countdown job. I'm going to take this 10 exclamation point and show you what I'm talking about. Watch. I'll move it in a minute. It's hard to see, but see what I did? I took the 10 and I multiplied. I did a multiplication sentence counting backwards, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? Now I do the same with the 7 underneath. Luckily, it'll be a little shorter. Okay? There you go. Now I'm ready to do this. The good news about, now the easy part. The good news is that the numbers that are the same on both sides of the bar cancel out, which means the 1s cancel out, the 2s cancel out, the 3s cancel out, the 4s cancel out, 5s cancel out, 6s cancel out, and 7 cancels out. Those are gone. So what's left over? Just these 3 numbers, 10, 9, 8. And notice the dots, of course, mean multiplication. I could also use parentheses, or just their basic classic X for the multiplication symbol. Doesn't really matter. Okay? So now I'm just multiplying 10 times 9 times 8. Well, associative property, 9 times 8 is 72. 72 times 10 is 720, and that's my final answer. There are 720 different combinations for these actors. Okay? And that's how you get your permutation. Hope you found that helpful. You could try your own, plug in your own real-life situation, maybe use your own numbers. You could always go back, pause, take notes, and try it on your own. Or try this one again. All right? I wish you luck. Talk to you later.